Hello.
Hey, ready?
Hey,
Hey,
Arjun.
Hey, you came back from the woods.
I know.
Why? I
I don't
mean,
know.
we enjoy you, but why? It
We
sounds
didn't have a
lovely.
choice.
Uh,
It's a struggle for survival. So, Arjun, I'm just going to listen in. So please run the meeting.
So we have Grant and CMAC here today, which is good news. We have the core people. So I think for today, we are just going through the Kubernetes process so we can define what key components will be likely for the memory fabric orchestration. And then later we can either see if any company has interest to contribute in any of the module or the components. So I think that's the main topic for today. Grant, are you able to help us go through the Kubernetes flow?
Hey, so sorry, give me just a second. Can you hear me?
Yeah, we can hear you.
Okay, sorry, I switched to my Mac and then tried to get my headphones to go, and it didn't work out as planned.
It does look like you are actually speaking far away from the speaker, though. Sounds like
Yeah, I am using my crappy web camera mic, which is
it. Much
always
better now.
the
Yeah.
worst idea. Yeah. Okay, I'm sorry. So what was the ask?
Can you just go through the Kubernetes workflow again so we can like define what the key components are during the whole like the whole flow, and potentially we can define like the um, uh, write something down or define architecture, and then later we can use for like software component contributions, etc.
Yeah, sure. Okay. So let me find. Oh, where is it? Sorry, I need to open up my OCP tab group. Here we go. Um, mm, 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 mm. Looking for the white paper. Um, I'm sorry, Hongjin, maybe to accelerate this, could you give a link to the white paper that you could post real quick?
Let me get it. I should have the draft version. Okay, so I'm posting the draft version in our shared Google Drive. Well, actually, I have the final version as well. The PDF one published.
Okay. I'm looking for.
The second one is the PDF officially published.
Awesome. Thank you. I thought we stashed the sequence diagram and a link in this document, but maybe we didn't. Um, shoot. Sorry, folks. Let me find it. Um, okay. Well, bum, 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 bum. This is annoying.
Hi, I'm Dongju from Samsung. In the meantime, I can talk in a little bit more context on it. So I'm working at the Ghost, working at Aram before, and we initialized one end-to-end Fabric included example for CXL memory pooling in this week. So it's called Pandia. I will left the link about that one. But at the same time, we are considering that because our team is contributing lots of Linux driver side for CXL memory uses, especially like DCD like things. So we are considering that making uh, the memory fabric interface and also utilizing with the DCD upstream patches connected with the uh, Kubernetes DRA interface as well. And if possible, want to contribute to the Kubernetes community too, like NVIDIA recently do for their DRA GPU, the module. So any other folks who are interested in that CXL memory pooling interface with the DRA? I believe the grant is currently we're talking about that one. Is that correct?
Um, yeah, yeah. I mean, so that's where this group needs to head. I found it. Thank you for thank you for filling up some time. Um, yeah. So DRA is, I think, the intercept for how CXL devices should be exposed to Kubernetes. But I think the orchestration logic also needs to be talked about. Um, so this is a good segue. Here, am I allowed to share? Is it working? Great. Okay. Um, so somewhere in the Google Drive, this exists, and I'm bad at Google Drive, so I just pulled it from my computer. Um, but these sequence diagrams, some of the Kubernetes side, it it disappeared. The need for it disappears, right? Because the DRA agent will help with some of the scheduling and stuff like that. But the orchestration logic taking like intent from the user also, um, like when somebody submits a Kubernetes pod and they're asking for CXL resources, um, that intent still needs to be communicated to some sort of scheduler. Kubernetes, their DRA resource mechanism, all it is just a way to carve off resources and um, basically make it so you don't have to restart the kubelet when you add more memory resources, right? So like that's all the DRA is going to get you. The DRA is just going to buy you the ability to add more memory to a kubelet runner without having to restart it. But like what memory should be added and how much and from where and from what local or Fabric attached resources is still non-existent for CXL, right? And so those are the things that we need to think about in this group. So definitely,
is DRA going to be contributed to Kubernetes? I mean, is that
it's
kind
already
of
in.
like
Yeah,
okay?
yeah, no. So the latest stable release is Yggdrasil, and that was January. So DRA with guardrails or something like that is what they call it, but that's already in Kubernetes. And so it's just a matter of like having the orchestrator fabric management component use it as opposed to like uh, the NRI interface or how we did it in this implementation a couple of years ago. So it's good. Like it's a positive because like some of the jankier components for how CXL memory gets plugged into Kubernetes have been resolved, but the whole like decision making flow so that the user can just ask for memory as opposed to like having to know the details of the Kubernetes cluster, those are still unresolved, right? Um, and so like this resource doesn't need to exist anymore because DRA exists, but like the monitor pod and the memory orchestrator and the agent, like these components, whatever it is that this group decides to call them, they still need to exist because something needs to make sure that the CXL resources haven't dipped off the system, and something needs to make sure that those CXL resources are being acquired, and then something needs to be telling these two things what to do, right? Like those are the big components that need an open source implementation. And then the rest of these Kubernetes components, and like there's no need for an init pod anymore because DRA is just a callable mechanism, so you don't need to set up an initialization pod to call a resource because the resource is just callable directly from the pod now. And like you don't need a reflector service because again it's just an embedded resource now, which is nice. And the scheduler will never change and the API will never change and the user won't change either, right? So it's good that we've taken a few of these owners off this list, but the how to like who's actually doing the resource carving and who's doing the resource advertisement and who's doing the resource composing, those three things, regardless of how Kubernetes has shifted, still need open source implementation, right? Does that make sense to everybody on the call?
Grant, yeah, go
Yeah.
ahead.
I just say CMX has a hand up.
Grant, to figure out what is the work that we need to do here at OCP, Composable Memory Systems, and what work is already being done somewhere else, could you tell me what is it that is missing from Kubernetes and Linux communities already work that can complete a system but has not been done yet, because of which we need to do it over here?
What I just said. Yeah. Yeah. So when
I
I
mean,
said that these things exist,
they have a complete system already, right?
I'm sorry, say that again.
They have a complete system. The system boots and runs. So what is it that they don't have that we need to help them?
Orchestration.
So they don't need orchestration?
No, they need orchestration. So Kubernetes, okay, let's yeah, that's a good idea. I kind of just launched into this diagram. Let's take a step back, right? So the Linux kernel, um, it there's it knows how to crack off CXL resources and it knows how to allocate CXL resources to tasks, correct? And there are some open source fabric managers out there that can do things with CXL fabrics and stuff like that. So like the act of like pulling together a VCS with some CXL resources and the act of attaching and onlining some CXL resources or growing or shrinking some DCD resources. Yeah, like Linux kernel has these things, and I think at this point, all of them have been upstreamed. The Fabric Manager, it just exists in the open source space. There's a couple of like Jackrabbit has an implementation that they open sourced, and a few other people I think have or are going to open source a Fabric Manager. But like that's just a RESTful API wrapper around a bunch of API calls, right? The thing that sits it so that's that. So like Linux has all the mechanics in place and they keep on improving the quality of those mechanics. So that's good. And then for Kubernetes, one of the things that was difficult about Kubernetes is just a resource scheduler in general, right? It doesn't actually care what the underlying thing is, just that it's scheduled it correctly as the user is asked, right? And so that just happens to be computer hardware, and that's great. And so the challenge with Kubernetes in the past was that when they first wrote the core scheduler, number of CPUs and amount of memory wasn't something that changed because it didn't, because it was 10 years ago and you couldn't bolt more memory onto a computer. It wasn't mainstream to do that, right? So the core scheduler never had a mechanism to grow or shrink memory or NUMA node count or any of that stuff. And so this Jackrabbit implementation sort of sidestepped that by doing it on the outside and then like sort of presenting it as this weird resource that was legal, but like you had to do this init pod thing and everything like that. And there was some extra stages to do it. When Kubernetes released the dynamic resource allocator specifically for GPUs, because you were going to be bolting on GPU DRAM that could be shared in a coherent space with just like CXL basically, but specifically for GPUs, that doesn't mean that CXL can't take advantage of it, right? And so now Kubernetes has a way to dynamically add resources like memory, which is great. So CXL drivers for CXL mechanics exist in Linux, and now Kubernetes, you can bolt memory onto a kubelet dynamically without having to restart the kubelet, which is great, right? Because we don't want to restart the kubelet because maybe the kubelet is running like 8 or 30 things and you don't want to reschedule 8 or 30 things just so that you can bolt memory onto it that may disappear in 20 minutes, right? So good. So dynamic memory in Kubernetes, CXL drivers, and support in Linux. But the gap in these two things is that when the user says to Kubernetes, hey, I'd like some CXL memory, Kubernetes is like, okay, how do I do that? Right? Because Kubernetes doesn't have discrete integration with CXL to go and like talk to a Fabric manager and go pull resources off CXL switch to create a VCS, or just talk to local backplane resources and like carve off a DCD pool or something like that. It doesn't have those mechanisms. And so what needs to exist within Kubernetes is something that schedules these sorts of things and interacts with the core Kubernetes scheduler so that resources can be dynamically pulled off in the way that the user intended them to be. And so like that's what OFM agent and the OFM monitor pod, and the memory orchestrator were kind of for, is that they sat there and did the CXL orchestration bits on the behalf of the core Kubernetes scheduler. And that's just how it should work in Kubernetes. Like Kubernetes doesn't at this point need to adopt or CXL semantics because CXL is not mature enough for the Kubernetes community to consider that. And so going through it in a control plane aspect in Kubernetes is a good path forward, because it'll demonstrate to the Kubernetes community that this is something that can be mature, and like they will eventually consider rolling it in, and then Kubernetes will just be batteries included with CXL at a later time.
This is very good explanation. Thank you, Grant. Now, Jeonju, to what extent is Samsung contributing either Pangea or Cognos, and which one of these gaps are we filling?
So here's my opinion. Like you mentioned, we have a multiple possible way to allocating the memory from the Linux right now, especially Jaguar made a mem block based. But we want to make it following the specification for dynamically allocating the memory, which is CXL 3.x DCD part. And that one is currently leading by us to upstreaming right now. It's not upstreamed yet. So our plan was on to upstream the DCD, and also likewise all others in the world right now. Everyone try to utilize Redfish for the sending this Fabric API. So we want to upstream the DCD related one to the Redfish as well. There might be, like Grant mentioned, we need some control panel somewhere. I don't know where it should be. And that one should be enabling to Kubernetes to allocating the memory. But here's unclear thing to me is that we planning to do those upstreaming all the interfaces and plan to contribute it as much as we can. But unclear things right now is to me is that which logic we can decide to allocate the memory to the Kubernetes. So for example, let's say we have a Fabric agent can functionally allocate or freeing the memory, then who decided is a huge problem. And at this point, Grant mentioned that Kubernetes had to be monitoring this one and deciding this memory as well. So that's the one possible way, but I'm still thinking that which is the best way to decide which logic and decide to where to making this one really possible to do that. But anyway, for the functional part, we planning to do the contributing the following the CXS specification, and I'm totally agree that we need a control panel and logical panel later as well. And I believe the Kubernetes is the right place at this moment.
Okay, then maybe to close the circle, the contributions we just talked about that Samsung is willing to do, should that come through OCP, or are we at this within this team identifying what those things are, and are we saying that the best place to contribute this is either into the Kubernetes framework or Linux streaming? What is our
Is a question to me?
This
To
is actually
us,
maybe a question, either to you, Grant, or even Reddy, or anybody else that wishes to. It seems that we are identifying some gaps. Question is, where do we fill the gap? Is this team trying to identify the gap and then also find the best place where it needs to be plugged?
Yeah, I think there are two things that we need, right? One is, I mean, it looks like the DCD plumbing requires some upstream work in Kubernetes. But before we go into DCD, if you were to just, carve out a piece of memory from the pooled, media, is something that we can do without going through the upstreaming work. what does it take to do that? And then actually enhance that with the DCD and say, for DCD, we need to do this. So it's important for us to actually come to a baseline understanding of what can we do now with the existing Kubernetes DRA plumbing, and what is that we cannot do, and what are the plans. So we kind of need some cohesive plan around it.
Yeah. So I mean, the simple thing here, sorry, the straightforward thing. Straightforward is always a better word. The straightforward thing is that the DRA mechanism, either the CXL semantics need to be presented to it, or it needs to be presented with an OFA, an OFM monitor pod management pod, so that the DRA mechanism can say, hey, a cube or a cube pod came up and said that they needed this type of resource, and so the Kubernetes scheduler tapped me, the DRA mechanism, and my code says that I should go bother you, monitor pod, about this. So go do your thing and then tell me how it went, right? Like, just write that. and then that component can be the one that goes and it does the DCD grow shrink, or cars off a region of a CXL device, or spins up attacks region, or whatever, right? Like, these are the connect points. It's either we're going to do something within the DRA component, or we're just going to do a small thing in the DRA component that then calls a different thing. Like, we have to decide how much we want to integrate with Kubernetes specifically, and then just do the plumbing so that the mature bits in Linux and the mature bits in Kubernetes can talk in a way that the user wants them to talk. Those are the attach points.
Right, and that will be part of MFM, right? The
Correct.
attach points, and we don't have to worry too much about we have to go change something here and there.
That's right. Yeah. Okay. So like the attach points are clear. I think what's unclear is who's doing the work and how it's going to be released to the community. Right.
Mm-hmm. Right. Okay.
That's also what I want to chime in. Or ideally, I want to, let's say, on the Kubernetes side, the memory is abstracted. It does not tie to CXL or the DCD capability. It should more like a generic composable memory. Whatever real technology behind it should be managed by the Fabric manager.
So the way I understood what Grant explained, and I think you guys agreed, was that there is some gap. Somebody needs to do the work, but then we are going to plug it back into Kubernetes or Linux upstream. Did I get it right? So it seems that somebody has to do the work. Maybe we are the ones. And when it plugs, is not OCP Marketplace. It is Linux upstreaming or Kubernetes framework.
Yeah, probably Kubernetes. And so this could exist in the OCP GitHub. And so like the components that are meaningful to Kubernetes, it could be a fork of those components within the OCP bounds. I think we have to check the licensing, because I know that OCP is GPL v3, and I don't remember what Kubernetes open source license is. We have to make sure they're compatible. And if they're not compatible, we need to talk to the OCP folks about if we can change the license for a repo, or if that's a no-no, because that'll be important for us for the contribution aspect. But I mean, the attach point is Kubernetes, because Linux, they're just gonna go, right? Like, they're just gonna make sure that CXL devices work. Getting it connected to Kubernetes is something that we would be doing, or just an organization, right?
Okay, so could we break the steps into at least two pieces? Since we're doing some work, we are OCP team here, we're doing some work here, could we identify what the work needs to be done I mean, you guys said it, but let's just recraft it into some document and call it maybe a requirements document, not the work, but what needs to be done. And then that could be credited somehow to OCP. Could go to either GitHub or OCP contribution database in a form of the output of this team, identifying what work needs to be done. Now, the individual members who belong to some other organizations that eventually the work needs to be done and be recognized and be credited outside, either Linux or Kubernetes framework, then the work gets done and follows our recommendation, and therefore everything fits well. Does this make sense?
Yeah. I think those are the steps. Yeah.
Yeah, this is what I think we want to get aligned with. To me, it's more like for this requirement, what key components we want, and what the interface or the API between each interface will look like. That help us to define like the boundaries of what components does what, and it helps with people to get a more concrete design.
So this again, what we agreed on seems to be different from jumping in and doing the code. It is the first step, identifying what needs to be done, write it down in the form of a simple document, maybe a framework, maybe a requirement doc, whatever we call it. And then the work starts following that recommendation.
Yep. Yes.
Yeah, totally agree.
So I can put together something, maybe a diagram, to highlight a few key components, and probably have a draft of the interface coming out from my mind, right? And then get further input from rest of you guys. Probably have a discussion in the next meeting. We'll call it something requirement.
Yeah, that sounds great.
Yeah, I think that makes sense.
Very good.
Okay.
Thank you.
Okay. Anything else for today? Donjo, I think is that what you talked about, the one presented yesterday at the CXL seminar? I'm not sure. Do this group want to hear that here? I mean, do we want to bring that topic to OCP, this group, or the Friday CMS group sometime? What's your think about it?
Pangaea. I think, I mean, depends on the group. From my understanding, what we should talk about in this the group is that likewise, other just talk about it. We need to define that which components for Fabric orchestration is needed. And I believe about that part, I can talk about what Pangea including it, like this one using the NRI and JagRabbit one. So, and then maybe I can talk about the next step include the grants, what just described, including DRA and possible technology. But what I believe is that here's all people kind of agree that in a similar architecture. So
Yep.
Then what we need to do right now is that the CMS just suggested we can making a more detailed and concrete requirement role and function between the each component. So at that point, I can present it if you guys want it. But currently Pangea have it. But if you are looking for that more spec definition, I think rather not to look at it is better, because if we are looking at some kinds of implementation in detail, then might be we are, like direct to that detail direction. So that's my current feeling, but let me know.
Yeah, I agree, right? I think content, once you actually bring up the component level view, right, and then we kind of review it here, agree that those are the right set of components and integration interfaces to those components, then identify where we see the gaps and what needs to be done in OCP and outside OCP, then you guys can actually present in CMS, all three of you and anybody else, right? So can present in CMS to give the whole picture of where things are. Till then, keep it in the sub team. Otherwise, it will be really confusing when you go and present something outlier, outside the scope of what's happening, right? So,
Yep, that's exactly my concern. But anyway, yeah, depends on.
Again, since we're part of OCP, Open Compute Project, and we want everything to be open, and sometimes some people don't wish everything to be open. They're willing to contribute something, but not everything.
right.
As we are identifying these components, identifying the work that needs to be done, if we are very careful about defining it in a modular way, clear inputs, clear outputs, and black boxing certain things in multiple modules, then contributors, the guys who are actually doing the code, might wish to provide different versions, a sophisticated one and a simple one, a binary one, a source code one, or they might come from different companies to plug it in. So I think as we sit down to write the requirements, if we be very careful about APIs, as you call it, or input-output interfaces, clearly defined, then people have a choice.
Yeah, exactly.
And then we can maybe have a race for a flag and say, okay, this is the module, and the guys who have contributed the most features or the most, I don't know, openness, they get a reward or something.
Is that going to come in from the OCP or our group?
The reward part of it, I don't know. It might come from the
I'll
individual
send you a link, CMAC. You can
company.
send me your PayPal.
Yeah, well, whatever.
And
I'm
not the
willing to
credit card.
contribute. If it is coming from me, the magnitude might be small. It will be a token. If it's coming from different organizations, it might be shiny and gold and other things.
Okay, I think we'll leave that component as an exercise to the reader. But Hongjin, thank you for assembling the ins and the outs, and look forward to reviewing it next time we meet.
Yeah, you're welcome. Yeah, I think, is there any other topic for today? Good. Let's save the 20 minutes from everyone, and let's meet in 2 weeks.
Thank you so much.
Thank you.
Nice to see you guys.
Thanks, folks.
Bye.
Thank you. Bye-bye.